This lesson is 8-5, and we're calling this part B because yesterday you were finding the volume of prisms. Today you're going to be finding the volume of cylinders. So the objective is to learn to find the volume of cylinders. So what is it that makes a cylinder a cylinder? It's the fact that the base that it has is a circle. And to find the volume of a cylinder, we're going to use this formula over here. And like with most of these formulas, they use this letter capital B. But I think for this lesson, you're going to find it much more helpful if you just use this bottom definition that they've given you, the pi r squared times h. And then the last thing that's down here that I do want you to notice that you might not even be able to see, but area is measured in square units while volume is measured in cubics. So whatever our units are, it's going to be units cubed with a 3 instead of with a 2 for volume, just like yesterday. So our very first example is a cylinder that has a radius of 4. We can see that this is a radius because it's only half of the distance across the circle. And then it's also giving us this height of 12. So the way that we're going to calculate is we're going to still, just like before, use our pi button and do the pi button last and then rounding to just one decimal place or the 10th on your calculator. Let's start with our formula, volume equals pi r squared times h. And now for the substitution, I'm going to substitute 4 in for my radius and 12 in for my height. From here I'm going to simplify, so I'm going to do my exponents first. And now I'm going to multiply 16 times 12 for a total of 192 pi inches. When we put this into the calculator, we do 192 times pi equals. We're going to get 603.18, and it's going to keep on going. Knowing that we want to round this to one decimal place, we want to take a look at this piece right here. If it's 5 or larger, we're going to round that first number up. So this is going to become 603.2 inches cubed. And that's our answer. So the volume of this cylinder is 603.2 cubic inches. The next example is a you-do problem, but I'm going to get you started just because these are brand new. So we're going to start with our formula. Off to the side here on our cylinder, we can start our substitution. They show us that our radius is 8 and that our height is 15. So I'm going to bring everything else in my formula down. So I'm bringing down pi and I'm bringing down squared. And now I'm going to simplify from here by doing our exponent first, and I'm going to go ahead and let you solve the rest from here. Make sure that you get it checked by me to see if you're doing things correctly. The next two are going to be examples that we do together. They're going to be we-dos because they are both changing dimensions. So this is going to start with an original cylinder that measures 3 centimeters with a radius on top of just 2. And we're going to explain whether tripling the radius or tripling the height of this cylinder would triple the amount of the volume. So we're going to think about the original cylinder first. So the original has a radius of 2 and a height of 3. So from there, you can see this simplifies down to 4, which is where they get this 4 pi times 3. So 4 pi times 3 is going to be 12 pi. And for now, I'm just going to leave it in terms of pi because I feel like it'll be easier to understand this way. So our original cylinder has a volume of 12 pi. This little guy right here. Now, to triple our radius, we're going to take our radius that's original, our measurement of 2, and we're going to triple that. So we're going to do radius equals 2 times 3 because we're going to triple it. So 2 times 3 is going to turn it into 6. So now instead of 2, we're going to use 6 in our equation. So volume equals pi r squared. This time our r is 6, and our height is still 3. When we square 6, we get 36. And when we multiply that out, we get 108 pi. So let's compare this. The original was 12, so I've put 12 down here. And then I've got 108, which is our new volume. So if I do 108 divided by 12, we end up getting the number 9. What this means is that when we triple the radius, we don't actually triple the volume. We're actually taking the volume and we're doing it times 9. So we're increasing it 9 times the original. So this didn't exactly turn out the way that we thought it would in the beginning. But now let's check it and see what's going to happen if we were to triple the height of this cylinder. So remember again that our original volume was 12 pi of our one cylinder. But now we're going to take it and we're going to figure it out if we were to triple the height. So let's start with our first part, the base, which is area equals pi r squared. Our original radius was 2, so I'm going to substitute 2 in for our radius. And the height is what we're going to be tripling. So this time the height is originally 3, but we're going to triple it, so we're going to do it times 3, which is going to give us a height of 9. So now we're going to put a 9 here instead of having a 3 there. And then we'll bring everything else down. So we'll start off by simplifying 2 to the second power, which is going to be 2 times 2 equaling 4. Bring down our 9, bring down our pi. And when we do 4 times 9, we end up getting a total of 36 pi. So let's compare 12 pi to 36 pi. Our original was 12. Our new one is 36. So when we do 36 divided by 12, we'll notice that we get 3. What this means is that when we triple the height, we triple the volume. So this one worked out kind of how we expected. And you can even kind of tell from these pictures, the original volume here, we're just doing it 3 times as much. Whereas the other one, we had this, and technically we're going to end up having, like 9 of those squeezed in there. Okay, here's another example where we have a juice can with a radius of 2, height of 5. And we're going to, again, triple the dimensions of the height and then triple the dimensions on the radius and see what kind of effect it has on the volume. And you can see I've given you the results there in your notes that it's going to triple when we triple the height, but it's going to actually do 9 times our volume when we do tripling the radius. And I just have that on your sheet for you. Okay, let's do one more together, and then I'm going to have you do a couple on your own. So we're going to do a drum company advertises a snare drum that's 4 inches high and 12 inches in diameter. So we really need to look at this word diameter here. We need to remember that a diameter stretches all the way across the top. And then here's our formula. In order to use our formula, we only can have radius. We can't use this with diameter. So we need to figure out what our radius is. And we know that a radius is just half of our diameter. So if our diameter is 12, then our radius is going to equal half of that, which is 6. So over here I'm going to be using 6. And then it gives us our height of 4 inches. So the height of our steel drum is 4. So I'm going to substitute that in also. So bring down everything else. We've got pi, 6 squared, and then 4. And they're all multiplied together. So I'm going to start by simplifying our exponent right here. So 6 times 6 is 36. And I'm going to bring down 4, bring down pi. So 36 times 4 is equal to 144 pi. So putting that into the calculator, I'm going to get a calculation of 452.3. And in keeping it consistent, we're going to round to the tenths. So we need to take a look at the second number after the one that we want to round to. So we want to round to the tenths, we're going to look at the hundredths. This number, if it's 5 or bigger, is going to cause our number to round up. So 8 is bigger than 5. So this is going to become 452. Instead of 3, it's going to round up to 4. And then our unit is in inches, and because we're doing volume, it's cubic inches. So that is the measurement and the volume of that snare drum. Okay, the next example is a U-do, and I'll get you started though. So this time we're talking about a bass drum. So we have a bass drum that is 9 inches high, and I'm going to attempt to draw that in. And then we have a diameter of 19 inches. So this one is 19. So again, you're going to have to divide by 2 so that you can get your radius, so that you can use the equation pi radius squared times height. And then you'll just start your substitution and make sure you have me check that. Finally, I'm going to have you do this last one on your own also. This is a cylinder that is giving us the measurement of a diameter on top. So make sure you pay attention to that it's a diameter given and not a radius. So you're going to need to solve for radius and then use your volume equals pi radius squared times height. And get your answers checked. And make sure that you show this to me that you've completed it so that I can get you your 5 points. You need to do that every time that you do video notes with me.